Hello and welcome. In this video, we're going to prove that the integral of dx over x root x squared minus 16 is equal to 1 over 4 sec inverse of x minus 4 plus c. Okay, and we're going to solve this integral using trigonometric substitution. Okay, so in trigonometric substitution, there are 3 points that we need to note. That when we know these 3 points, we'll be able to solve any problem on trigonometric substitution. So the first point is that whenever we have the expression a squared minus x squared, right, we're going to substitute x as a sine theta. Whenever we have a squared plus x squared, I'm going to substitute x as a tan theta. And whenever we have x squared minus a squared, we're going to substitute x with a sec theta. Now, when we take a look at this expression x squared minus 16, comparing it with these 3 points, we can say we can compare it to point number 3. It agrees with point number 3. So I can write this as x squared minus 4 squared. And it agrees with x squared minus a squared. Okay? So that means that a is equal to 4. And I'm going to substitute x with 4 sec theta. Alright? So I'm going to come back to my question and say that my integral becomes dx, or let me just write it this way, 1 over, what is x? X is 4 sec theta, 4 sec theta, root x squared, x is 4 sec theta, so 4 sec theta all squared, right, minus 16 dx. Okay, so this is one variable theta, this is another variable x. I want all the variables to be uniform, right, to be the same. So I'm going to differentiate x with respect to theta. So dx, the theta becomes, when I differentiate sec theta, I'm going to have sec theta tan theta. So this becomes 4 sec theta tan theta. Alright, so dx becomes 4 sec theta tan theta d theta. Okay, so I'm going to replace dx with this guy right here, 4 sec theta tan theta d theta. Okay, so the integral becomes the integral of 1 over 4 sec theta roots, let's just do this. This becomes 4 sec theta squared becomes 16 sec squared theta minus 16, right? And then dx becomes 4, let me just write it here, 4 sec theta tan theta d theta. Now at this point, let's simplify and say that this becomes the integral of 1 over 4 sec theta and the square root of 16 into sec squared theta minus 1, right? And then we have 4 sec theta tan theta d theta. Okay, now how else can we write sec squared theta minus 1? Now is the time for us to remember our laws of trigonometry. So when we say sine squared theta plus cos squared theta equals 1, if you divide through by sine squared theta, sine squared theta, sine squared theta, sine squared theta, this becomes 1 plus cot, right? Cot squared. Sine divided by cos is tan. Okay, so cos divided by sine is the opposite. So we have cot squared theta, and that is equal to cosec, right? 1 over sine is cosec, so cosec squared theta. So likewise, when we divide through by cos, we have sine squared theta divided by cos squared theta plus cos squared theta, right? Divided by cos squared theta equals to 1 divided by cos squared theta. Okay? Here we divided through by sine. Now we're dividing through by cos. Okay? We're going to have tan, right? Tan squared theta plus 1 equals to sec squared theta. Right? And so when we write it the way we have it here, we discover that tan squared theta is equal to sec squared theta minus 1. Okay, so we're going to replace sec squared theta minus 1 with tan squared theta. And so we're going to have the integral to be the integral of 1 over 4 sec theta, right? Let's write that well. 4 sec theta, right? Root 16 tan squared theta, right? Then we have 4 sec theta tan theta d theta. Okay, so this becomes the integral of 1 over 4 sec theta. 4 sec theta, square root of 16 is 4, so multiply by 4. Square root of tan squared theta is tan theta. Tan theta, let's write that well as well. Tan theta, and then 4 sec theta tan theta d theta. Okay, and so it becomes the integral of 1 over 16 sec theta tan theta, then 4 sec theta tan theta d theta. Okay, so sec theta tan theta cancels out. You are left with the integral of, let's divide this. 4 divided by 16, we have 1 over 4 d theta. Okay, and now when we integrate this, this becomes 1 over 4 theta plus c. But we're differentiating with respect to x, right? So our answer must be in terms of x. So we have to recall that at the beginning, we said that x equals to a sec theta. And we said that a is 4. So x equals to 4 sec theta. Okay, so we're going to make theta the subject, divide both sides by 4. Sec theta equals to x over 4. And then theta equals to x over 4. Theta equals to the sec inverse of x over 4. Right? Sec inverse of x over 4. So we're going to come back here and say that our answer is 1 over 4. 1 over 4, so write that well. 1 over 4 sec inverse of x over 4 plus c, which is exactly what we have here. So we have successfully proven this integral. Thank you very much for watching. Don't forget to like, share, subscribe. See you in the next video.